Thanks, David and Gail. We all know each other now. That's great. We all got introduced. You heard me mention I'm from the National University of Singapore. You might wonder why I came all the way here to Berkeley today. We actually have had a long-standing collaboration with Center for the Built Environment over a decade, with Stefano Scavan leading the way. I've been a professor at NUS now for 8 years. Today I'm going to talk about a project, maybe something out of the ordinary when it comes to interacting between the built environment and occupants or humans. You all probably have heard, if you've come to this meeting or you know a lot about CBE, you know that Center for Built Environment has a really popular common survey, which is collecting information from occupants in the built environment to kind of capture their experiences, whether it's thermal comfort, noise, light, all the different elements of indoor environmental quality this survey covers. So this is kind of really one of the biggest efforts of this kind of collecting information from occupants in the built environment to characterize the way spaces work. You might also know that information flows back to occupants, right? We have thermostats, we might have little dashboards, we have little interfaces that allow the building to give information about how it's operating. So we have this kind of two-way communication between occupants and the built environment and the people that operate buildings, and then the other direction towards the occupants in terms of how buildings are operated. But this is kind of, there's a lot of value to that, but can we do better? Can we learn from other ways that we have kind of interaction in our lives between systems and people? So all of you that have ever used, the internet or smartphones or social media know that there is a way that we give information all the time into social media and online platforms. We give a like, we give a star rating to indicate how we feel about something. In our digital lives, we spend a lot of time giving information back to these systems. And there are a lot of mechanisms that send information back to us. Obviously, we read our emails and all those kind of things. But there are also these mechanisms, for example, in fitness wearables. If anybody in the room has a Fitbit or an Apple Watch or something like that, I heard there's people from Google, so of course they have Fitbits. You know that these give kind of insights on or actionable nudges, let's say, to do something, usually related to fitness. So stand up, take a few more steps, things like that. My Apple Watch tells me I need to do breathing exercises once in a while. Maybe it understands how stressed out professors can get. So there's this kind of two-way communication in our digital lives that we, in our research lab at NUS in collaboration with CBE, have been looking at ways, how can we use these techniques to improve this built environment information exchange? How can we create this kind of like button for spaces and indoor and outdoor spaces? And how can we nudge people? How can we give them information that, for example, tells them, it's nice outside, open the window, something like that, based on what I just spoke about in the social media context. So for the last 6-7 years, we've been developing this project called Project Cozy. It's an open source web-based platform that uses smartwatches and smartphones to do this kind of two-way interaction between occupants and the built environment. It's an open source project, so I'll show you in a second how we use it, how we collect data using it, but we're really proud to say that thousands, even hundreds of thousands of data points have been collected across the world. We had an older version on Fitbit, and now we also have a platform using iOS. And really over 100,000 microsurveys being collected across the world with relation to the built environment. And this is the kind of the main interface of Cozy. There's a smartwatch and smartphone element to it. The smartwatch is what's called microsurvey kind of interface. So little surveys like what you see here about thermal preference that collect that information, that provide that like button kind of interface for occupants wherever they may be in indoor, outdoor spaces and different parts of their daily lives. Here you see smartphone screenshots as well that kind of give you an indication of the different parameters that you can set in the application about when a certain question flow is served and how the data is collected. And from a research perspective, we're actually not really, we're kind of leveraging techniques that have been used quite a bit in social sciences and public health, the stand up and take a few steps kind of thing with fitness wearables. We're just leveraging techniques, a couple of which I'll show in a second. One is called ecological momentary assessments. And in the case of a watch, we call it micro EMAs or micro ecological momentary assessments, collecting information about people's experiences throughout their daily lives. And then the other side of it, as you saw from the title of my talk, is sending information back, that nudge. And this in the research communities are called JITIs, just-in-time adaptive interventions. And here you see a couple of examples. I'll talk about a big study that we did in Singapore, which used both of these methods of collecting information and sending information back. The JITIs are really triggered based on environmental phenomena, different types of data streams. And if you're curious, there's a lot of details that if you want to ask questions later or come find me to talk about. And like I said, we deployed this in Singapore in 2022 and 2023. We were able to recruit 100 participants across Singapore, and they were asked to wear a wearable that they maybe already own. And if they didn't, we would provide one. And they would wear it for about a month. And over the course of that month, whenever the watch would kind of vibrate, they would fill out the micro survey about their experience, their environmental experiences. And then at some point in the study, we would start sending these JITI messages back to them. And this is just one example. In this study, we had two very simple kind of nudges. One of them was related to noise. The other related to thermal comfort. Here you can see that it's kind of this generic message about, put in headphones, there might be noise distractions nearby, or change locations or things like that. And the EMA, just to give you a sense of how an EMA structure works, I'm not going to go into the details of every single question, but generally we create these question flows. Here you see the first part of our question flow capturing the subjective experience related to noise and thermal preference. And then there are these drill downs. So if there's a noise issue nearby, what could be the source of that issue? Then we want to contextualize the data. What type of space are you in? Indoor, outdoor spaces? And then specific spaces we drill down even more deeply. We do get GPS location from the iOS platform, but this helps us really kind of solidify that ground truth of where people are. And then finally, last but not least, the social context. So it also matters who you're with and what you're doing when it comes to noise and thermal preferences. I'm not going to show I don't have time to show you all the results, but I can show you that we collected a lot of data. We had over 12,000 microsurvey responses across Singapore. We were able to send back to the participants over 3,600 intervention messages. And we're really processing those data now. We have a couple of papers that are in the publication process, one of them pre-printed. And the one that we've pre-printed, you can check out already, is showing, we kind of tried to characterize these JITI messages and how helpful they are. So this is a slide showing just one of we had a weekly survey as well. People would fill out a phone-based weekly survey. And this is one of the questions from the survey, which was asking people, were these intervention messages were they helpful in understanding their indoor environmental satisfaction? And we had a fair number of people saying, yes, this was helpful, this was interesting. But on the other hand, we found that a lot of people weren't getting JITI messages because the triggering mechanisms and the different logical structures of how those messages were sent just weren't occurring for quite a few of the participants in this phase. So lots of interesting sort of results that we're sifting through, and you can ask questions about if you'd like. We've since gone on to also use the data for machine learning. My group is called the Building and Urban Data Science Lab. We train machine learning models. We created a machine learning competition on the Kaggle platform. If you're interested at all in learning how to create machine learning models, this is an amazing platform to learn from. And there's a data set and kind of example of analyzing these types of data. We've also been utilizing these data and the COSI platform for an urban scale outdoor heat stress study that we're doing at NUS. I'm not going to ask you to raise your hands, but many of you in the room have probably been to Singapore. You know it is the opposite of the Bay Area. It's always hot and humid as opposed to nice and cool and dry. So we did this study on our campus where we have a person walking around a certain predefined route and filling out microsurveys as they go. As you can see, the little watches pop up. And then we're doing a technique called data fusion. We're merging those microsurveys with street view imagery, sensor data, weather stations, and even sensors attached that the person's carrying while they go through the campus. So it's really characterize heat stress, the exposure of heat to the person, and how it can be characterized. And last but not least, a really amazing study you might hear of in future CBE meetings because it's just kicking off, is a collaboration with Stefano and Hui Zhang and Tom Parkinson, who you might have recognized from previous CBE meetings, in addition to Jason Lee and June Lowe, who are medical school experts in heat stress and physiology, as well as sleep. And the focus of this study is really about sleep and people's exposure to heat throughout their daily lives, and then and characterization of their sleep environments in Singapore. And there's really two ways you sleep in Singapore, with air conditioning or with a fan. And so we're trying to characterize that using COSI, and we are kind of structuring the protocol based on lessons learned. We're asking people to fill out microsurveys before and after they go to sleep, as well as capturing a lot of information about their bedroom environments. Last but not least, also the adoption. I mentioned this is an open source project, so everybody in this room is free to clone the repository, to spin up their own version of the app, create their own microsurveys. Here is some logos of universities mostly that you see on the left, and a company, Kojima, a company in Singapore that's a Japanese construction company that has cloned the project and is using it for indoor environmental characterization in buildings in Singapore and Japan. And we also host the app, so you can also make your own question flows using our backend as well, as a collaborative effort. But I'm happy to entertain questions and would love to talk to anybody who's interested. Of course, lots of people involved. And if you have questions, I think there's a little bit of time for that. And there's a QR code here. If you'd like to download my slides, you can do that in PDF form. Thank you.